All right, so I'm going to put up on the screen just a summary because I browsed through the final exam. I'm not showing the final exam on the screen, but I browsed through the final exam and wrote down samples of all the problems. There were 28 problems. Pretty sure that was correct. 28 problems on the final exam for this class. And it's just basically what we've studied all semester. If you want to have good review for it, go back and look at the test you've taken this semester, or if there's a practice test for that, you can go take the practice test again on any of those. If you want to get warmed up for, things we did back in September and October, go back and look at those tests. See if you still know how to solve those type of problems. Go back to the practice test. See if you can still solve those problems that you did then. So, okay. That's probably the best way to review for it, because a lot of these final exam questions are going to be just like the ones that were on the unit tests. So I'm going to put this up on the screen. Let's take a look at what I pulled from the final similar type problems. Like I said, these aren't exactly the problems that are in the final, but they're similar. So I just made notes, just wrote all these down on a piece of paper. So if you remember all the way back at the beginning of the year, we had systems of equations. So we have this systems equation, y equals 4x plus 3, x plus y equals negative 2. If you remember correctly, we had 3 ways to solve a systems of equation. One was by elimination, where we would move the x over here with the y, and we would try to get a plus x and a minus x, or a plus y and a minus I that cancel each other out. We eliminate one of them and solve for the other, and then go back and substitute that solution to find the other variable. Or we could use substitution, which this one is set up perfectly for substitution because we already have y equals. So since y equals this, we could take 4x plus 3 and substitute it for y in the second equation. So we have x plus 4x plus 3 equals negative 2, which means we now have 5x because x plus 4x is 5x. Subtract 3 to move to the other side. 5x equals negative 5. So x equals negative 1. And since x equals negative 1, we can substitute negative 1 plus y equals negative 2. Add 1 to each side, and y equals negative 1. So systems of equations. You could also solve by graphing. If you remember, that's the third way. Elimination and substitution are graphing. So if we were graphing, and when I'm taking the final, if I was taking the final, I would definitely have Desmos open. I would definitely be using Desmos. So if I wanted to look at this 4x plus 3, and I wanted to solve it by graphing, let me just type that in while I can see it on the screen. Equals 4x plus 3. And the second equation is x plus y equals negative 2. Look, there's the solution, negative 1, negative 1. Same that we found by substitution. So use Desmos, to help you. There's system equations solving by graphing. So that is a valid method of solving systems of equation. We also had problems like this, solve, which means find what the x equals. This is an x squared. This is an x plus 2 squared equation. So since x is being squared and it equals 64, to solve that, you're going to take the square root of both sides. If you do it to one side, you got to do it to the other side. So the square root of x plus 2 squared cancels each other out. So it's just x plus 2 equals 64. We got to take the square root of that. Here, let me see if I can jot down some notes on how we solve this. All right, so if I'm solving that, I take the square root of both sides, x plus 2 squared equals the square root of 64. Square root and square cancel each other out, so it's just x plus 2. Those are opposites. And this is either plus or minus 8. So that means x plus 2 equals 8, and x plus 2 equals negative 8. So when you subtract 2, x equals 6, or x equals negative 10. There's the solutions. 6 or negative 10. So be prepared to solve a problem like that. Over here, it gives you two equations. X squared minus 2x plus 1, negative 2x to the third minus x minus 2. Choose the graph. I will mention all of the test is multiple choice. So have you a pencil and paper so you can work problems like this. And then I'm going to look for the multiple choice that has these two answers, 6 and negative 10. This one would give you 4 different graphs, and you choose the graph that represents that systems of equations. What would I do in that? I would go to Desmos, and I would graph both of those, and then look for the graph that matches it on the multiple choice. Simplify. Let's look at that one. If we're simplifying the square root of negative 72, you try to break that down into numbers that you can take the square root of. The first thing is, though, we have a negative. So this is the same as square root of negative 1 times 72, which we know that is I square root of 72. Remember, the square root of negative 1 is I. So we can pull I out of there. Now we just have the square root of 72. So you want to try to find numbers that you can take the square root of that are factors of 72. So that's the same as 36 times 2. 72 is 36 times 2. And we know what the square root of 36 is. So this is 6i square root of 2. That is what it simplifies to. 6 times I square root of 2. So that's how you would work that one. Find the product. That's just simply multiplying those together. Product means multiply. So you got to write 2x times 3x and then 2x times negative 5. And then you multiply 1 times 3x and 1 times negative 5. It's the distributive property that you've used for years in math now. So you can do that. Remember, 2x times 3x would be 6x squared. So that'd be your first term. What would be the fastest and most efficient way to factor this equation right here? And we know it's a quadratic. There's lots of ways to factor it. You can complete the square. You can use just factoring itself. But if you look at this, this is x squared and 49. Those are both perfect squares. So the most efficient way, and it lists four choices. This is the difference of squares. Difference of squares. That'd be the fastest way to do it. Because difference of squares says, oh, just make it x plus 7, x minus 7. There, we're done factoring. X plus 7, x minus 7. That's what x squared minus 49 would factor to. Difference of squares. What is the domain? Which means all the possible x's. If you're not sure, graph it. Graph it. Now, this is a quadratic equation. It's going to be a parabola. So we don't know the domain is all real numbers. All real numbers. Over here, what's the greatest common factor of negative 4x squared y minus 24x? Greatest common factor. Well, let's see. I can pull negative 4 out of both. There's x squared and an x. I can pull out an x. This only has a y, that doesn't. So if I factor that out, that leaves an x and a y. And over here, it just leaves a plus 6. Because I pulled negative 4, divided negative 4 out of negative 24. And I divided x out of x. So this is what it factors to, greatest common factor. The greatest common factor, your choices might just list that, because that is the greatest common factor of both terms there. Which equation has zeros of x equals 2 and x equals negative 1/2? And it's going to list 4 equations. So I would just graph them. That'd be the easiest. Or you can solve all 4 of them to figure out the solutions. But if you graph it, and I'm wondering, let me just make up an equation. It's like, okay, if I'm looking at the equations it gave me. Maybe the first one is y equals 2x squared minus 5x plus 3. What are the answers? 1 and 1.5. 1 and 3 halves. 1 and 1.5. Was that what I was looking for? No, this one was 2 and negative 1/2. So that equation wasn't it. I would just graph them and see what the solutions are. Here's what it says solve. 2x squared minus x plus 1. Well, there's different ways to solve quadratics. One is by graphing if the solutions are real solutions. Let's graph that and see if we can solve it that way. 2x squared minus x plus 1.
Bill Gates, what a nerd.
2x squared minus x plus 1. Uh-oh. It doesn't touch the x-axis, so those are not real solutions. So if it's not real solutions, that tells you instantly to solve this. There we go. To solve this, we're going to need to use the quadratic formula. So if you don't have this in your notes, this would be a great time to write it down because you're going to need it on the final. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. That is the quadratic formula. And that comes from f of x equals ax squared plus bx plus c. There's where your a, b, and c are. A, B, and C. So when you look at this equation that we're solving right here, A equals 2, because that's the coefficient of the x squared. B, what's the coefficient there? We got negative x, so the coefficient is negative 1. And for C, it's just whatever the constant is there at the end. So we can take this and substitute it in. Negative b. Since b is negative 1, negative 1 would be a positive 1. Plus or minus the square root. B squared would be negative 1 squared, which is just 1, minus 4 times a times c, all over 2 times a, or 4. Now we simplify. X equals 1 plus or minus 1 minus 4 times 2 times 1. Well, that's 8. 1 minus 8, negative 7 over 4. We can pull out I. So x equals 1 plus or minus I square roots of 7 over 4. Those are the two solutions to that quadratic equation. 1 plus I square roots of 7 over 4 and 1 minus I square roots of 7 over 4. That's the answer to solve right there. So you would look for this in your multiple choice. Again, the problem with the test to be different with this one. I just wrote down a sample program. Sample problem. Here's when you factor completely. Oh, let's look at that one because that one looks a little tricky.
Gotta get back to your assignment since I took you off track.
And the first thing I see is, oh, I can factor out a 3, but I have to do this by completing this square. Well, maybe not. Maybe I can just factor out a 3. Let's see.
This one right here, about
X squared plus x minus 6. Oh, yeah, that'll factor because I'm looking for numbers that multiply together to be negative 6, but add together to be 1. So what multiplies together to be negative 6? 1 and 6, 2 and 3, and one of them has to be negative. So if I use 2 and 3 with a -2, this is x minus 2x plus 3, and we have a 3. So that is factored completely right there. This equation factored to 3, x minus 2x plus 3. Yeah, that wasn't too bad. Let's see. Oh, we'll have something like this where they'll give you an f of x equation, x minus 3. They'll give you a g of x equation, which in this case is 2x squared plus. Well, that's where you take the g of x right here and substitute it in for x right there, and then simplify. Whatever's inside this parentheses, substitute it in to f of x. This one says find h of g of 3. Oh, that's got 2 steps. Let's work on that. So let's see. H, I want to write down what h of x is. It is 5x plus 5. And g of x is 2x squared plus 1. All right, and they want us to find h of g of 3. Okay, so I wrote down what h of x was and what g of x is. So work from the inside out. First, let's find g of 3. So g of 3 means I take out the x and I put in a 3. So this would be 3 squared. 3 squared. Instead of x squared, it's 3 squared. So this is 2 times 9 plus 1. That's 18 plus. So this is 19. That's what g of 3 equals. So now I can go over here. Instead of g of 3, I know it's 19. That's what g of 3 is. So I'm going to put 19. So I'll substitute 19 into here. H of 19 equals 5 times 19 plus 5. 5 times 19 is 95. Oh, so it equals 100. That's what h of g of 3 equals. I look for that in my multiple choice.
Do not make Mr. Martin's Tuesday bad.
And then this one just says, what is f plus h of x? Well, you just take these, add them together. X plus 5x, -3 plus 5. So 6x plus 2. That's what the answer would be then. Let's see. What are the possible solutions for a system of equations? Now we're talking about linear systems. With linear systems of equations, you got, let's see, what's possible? Linear systems of equations. You have no solution, which means they don't touch each other at all. You have one solution. Or infinitely many. Put it that way. Infinitely many solutions. So you're looking for the multiple choice option that has this: no solution, one solution, infinitely many. Because if we looked at on Desmos, let's do that. If we have a linear systems of equations, y equals 2x minus 9, and then we have y equals -x plus 3. This one has one solution. That has one solution. It's possible to have no solutions. These will never touch. They're parallel to each other. There's no solution there. They never touch. Or it's possible to have an infinite number of solutions when these are the same line. See, the purple and the green are the same line. So every number is a solution that's on those lines because it's on every single line. So that's your choices: infinite, one, or none. They could have one. That's your choices. Let's see. You may see a problem like this. Well, you will see a problem like this. Which is true about the graphs of, and look, these are both quadratic equations in vertex form. This is vertex form. Two times x minus 4 squared minus 2, and 4 times x plus 4 squared minus 2. And it'll have questions. What's true? Do they both have the same vertices and the same shape? Do they have the same vertices and a different shape? Do they have the different vertices and the same shape, or different vertices and a different shape? Same and difference. So if you don't know, go graph those. 2x minus 4 y equals 2x minus 4 squared minus 2. Was it minus 2? Yeah, they're both minus 2. Oh, that was not supposed to be x, supposed to be 2. And this one was 4.
Oh, and I don't have.
Did I do that right? Yeah. X plus 4 squared minus 2. So there are the two that I have on this page. Do they have the same vertices or the same shape? Or different or what? Well, they definitely have different vertices. The vertex over here is 4 and negative 2. The vertex over here is negative 4 and negative 2. Different. And look, they're the different shape. If I put one on top of the other one, you do that. Let me move it over. See if they're a different shape. One's skinnier than the other.
Oh,
Different shape. So these have different vertices, different shapes. There'll be an inverse problem. What is the inverse of this? Oh, that's probably a good one to work there, Mr. Brock. All right, we can work that. Inverse. So if f of x
what, 3?
equals square root of x minus 1. All right, let's remember the 4 steps of finding an inverse. Step number 1, change it to y equals. Step number 2, swap places with all the x's and the y, which in this case is only one x and one y, so they just trade places. Step number 3, solve for y. So to solve this, I got to square both sides because I got to get rid of that square root. So this becomes x squared, and this cancels each other out. Square root and square means this is just y minus 1. Add 1 to both sides. So y equals x squared plus 1. I just swap places with them to make it better. And then step number 4 is write it back in function notation as the inverse. This is the inverse function. So this is what I'm looking for in my multiple choice answers. The inverse is x squared plus 1. The inverse of this. All right.
Annabelle, what's the next step?
I have some more on the back. Just 7 there. What are the x-intercepts of x squared plus 2x minus 3? If I'm taking this test, I'm graphing that.
My goodness. Go, Annabelle, go to the.
So it's x squared plus 2x minus 3. X squared plus 2x minus 3. Oh, I put an equals there. There we go.
Oh, here we go.
There's my x-intercepts. Don't make that hard. If I want to know what the x-intercepts are, I'll graph it. So that's the x-intercepts. What is the vertex? Well, you got 2 choices there. You can complete the square and put it in vertex form, or I'm graphing it.
You totally can. You can be like, I think.
X squared minus 3x plus 2. There's my vertex. It's 1.5 negative 1/4 or 0.25. Make it easy on yourself. Let's see. Convert. No, okay. This one we can't graph because that doesn't help us. Convert to vertex form. So we need to complete the square. So let's practice one of those completing this square. 3x squared minus 6x plus 7. And we set it equal to 0 to complete the square. So there we've got this 3x squared minus 6x plus 7. We're going to complete the square. So to complete the square, first we need to get the constant on the other side.
So go up there and click up there.
So we're going to write 3x squared minus 6x equals negative 7. Now, if I can, I go ahead and factor out any number I can. And I can factor out a number. I can factor out 3. So I've got x squared minus 2x. I'm going to leave myself some space in there. Now I do the completing the square. Now remember, you take this middle term, the negative 2, and I divide it in half. Negative 2 divided by 2. That's negative 1. So that tells me this is x minus 1 squared. But I need to square this to figure out what I'm adding. Negative 1 squared is just plus 1. So since I added plus 1 on this side of the equal sign, I have to add to this side to make it equal. But I didn't add plus 1 to the left side because everything in the parentheses, everything inside here is being multiplied by 3. So when I put something in the parentheses, it's actually 3 times larger. So I added 3. I've got to add 3 over here to balance it. Because I added 3 on this side, I added 3 on this side. Because everything inside there is 3 times bigger than what it shows.
Okay.
So this is 3x minus 1 squared because this is now a perfect square trinomial. Because we created it to be that way by adding this plus 1 on the end. And it equals negative 4.
Yeah.
So to put it in vertex form, like f of x equals 3x minus 1 squared, we got to move this back on that side with it, plus 4. This is now in vertex form. And looking at it, since we know the vertex is x minus h plus k, right? And we have a whatever the coefficient, x minus hk. We know the vertex is 1, 4. Not that it asked that, but since we have vertex form, h and k is the vertex. And since that's a minus, x minus h, x minus k, x minus 1.
If you click on home, it'll come right back.
Oh, the k is at whatever it is in the end, plus 4.
Yeah.
So that is how we solve converting the vertex form. Describe the transformation. If we start with x squared and we end up with x minus 1 squared minus 3, we know this is down 3. And this is left or right. If it's a minus with the x, that means it's right 1.
Okay. You have those on your drive already?
Right 1 down 3. If you're not sure, again, Desmos to the rescue.
Like when you shared
Let's do y equals x squared first. That's the original x squared. And then let's do x minus 1 squared minus 3.
you have there on the right
X
hand
minus
side.
1 squared minus 3. Where'd it go? It went right 1 and down 3. Just like we thought. Right 1, down 3. What is the axis of symmetry? Remember, you can find that by negative b over 2a. X equals. It's a b.
So that's
Or I can graph it. Negative b over 2a. Negative 6 over 2 times 3. 2 times 3 is 6. So negative 6 over 6. Negative 1 is what we expected. But let's graph it and see. 3x squared. 3x
and then
squared plus 6x minus 2. Oh, look, -1. So x equals -1 is the axis of symmetry. It goes through the vertex. Whatever the x coordinate is in the vertex is the axis of symmetry. Which we can also find with -b/2a. Let's see. If the graph of f of x equals x squared is translated 3 to the left and up 1, what's the equation? And it'll give you a list of 4 equations to choose from. 3 left. That means this will be x plus 3. Because this went right when it was negative. And this will go up 1. You can graph those 4 equations and see which one moved 3 left and up 1, if that helps you. Desmos. And let's look at this problem. If the coefficient of a x plus 2 squared is greater than 0 and it increases, what's happening? Well, I can use Desmos for that too.
But if you do the best you possibly could.
Okay, so if I write, and I can write exactly like that, it goes a x minus 2 squared. X plus 2 squared. Okay, x plus 2. And it says right here, would you like to add a slider? Well, yes, I would. And I click that button. Okay, when a is 1, here's what it looks like. So the question asks, what happens as a increases? Well, let's make it increase and see what happens. Oh, look what's happening. As a is increasing, it narrows. It gets skinnier. See, a back here. Bigger a gets, the skinnier the graph gets.
Is your other best friend named Camden?
So that's it. That is pretty much all of the final exam that you will see later this week, from the last time we meet this semester. So that gives you some things to look at. You can go back to the practice test or the exams and pull some other problems that are exactly like this, and you can work those, make sure you know what you're doing. But this is what you're looking at for the final exam. These are all very similar to problems you will see.